And since machine learning only theoretical sessions are not enough, it is a demand that you implement these things, okay? Then only you will understand it better. Because every you can say every data set will require some other type of pre-processing, other type of data handling. So once you try at least one question by yourself, you will get some idea. You will learn something new. And I hope, Pratik, you have tried, you have during pre-processing, you have checked the null values and duplicated values. If not, add that as
Yes,
well. Now, today we are
I
going
have
to
already.
start with the ensemble method. Basically, this is the topic which we discuss at the end when the machine learning, all the machine learning algorithm we have discussed. The reason I'm discussing it after decision tree because we are going to discuss one of the thing which is random forest, okay, which is quite similar to your decision tree. This is the reason after decision tree I'm taking this topic into consideration. Okay, so if you remember, I'm revising this again. In machine learning algorithm, we have categorized it into three categories: supervised, unsupervised, and
Reinforcement,
supervised, unsupervised, and
reinforcement learning.
reinforcement.
Semi-supervised.
Semi-supervised, no, reinforcement.
Okay,
Okay,
okay, yes, ma'am.
now supervised, in supervised, I have told you that there will be two categories: classification and regression. I'm expecting answers from you. These are the broad classification. You should know about this. Now, we have discussed one of the example, which is decision tree. Okay. Using decision tree, you can solve both these problems, classification and regression. That is why it is also known as CART algorithm. Okay. Now, there are several other algorithms in classification and regression algorithm. Like in classification, you will see SVM or KNN and many other algorithms. Okay. In regression also, you will see several other algorithms. So one algorithm I have discussed, like what kind of problem we face there and how we solve it, how we implement this. Other algorithms you can study, you can try to implement, and if you face any difficulty, you can come up with your doubt. As you all know, all the algorithms we cannot discuss over here. Okay, now then in unsupervised algorithm, I have told you that there will be clustering and association. Okay, so clustering I'm going to discuss in detail by taking k-means algorithm as an example. Okay, and if there are other algorithms as well in clustering, you can try it out. Okay, one of it I'll give you the practical demo as well. Okay, then we have association as well, for which I'll show you that basically how we do that. If you remember that big mart example, okay, association we place there, how to place items into a shop or a market. Okay, so association is there. Now, uh, what we do basically, we have some data set, we give that data set to particular algorithm, we train our model and we get the output, right? Now, what will happen if instead of giving my data set to just one algorithm, I'll give my data set to multiple algorithm and I'll ask my and then I'll get the output. Okay, means I have not given data set to only just one algorithm. I have given data set to multiple algorithm. Those multiple algorithm, based on those multiple algorithm, my data set will be trained, my model will be trained, and each of these model will give you some output, right? Now, these output, what we do, we will take the maximum one, or we will do the averaging, or we will do the weighted averaging. All those type of thing we can do to get the final output. Okay, let's suppose I have five output. I will see what is the output where I'm getting the maximum one, and I'll take that maximum one as my final output. Okay, like this, if I'll do what kind of what do you think? Giving data set to only one algorithm is good, or giving data set to multiple algorithm is good?
Uh, Giving it to multiple will be like we will be able to decide which one is working better now.
Hmm. Giving to multiple algorithm will be a good approach, you can say. For example, suppose you tomorrow you have a big day. Okay, maybe a job interview or your first day of job or your first day of college, something like that. There's a big day. Okay, now you have two dresses. You'll go to your sister or a brother. Okay, you'll ask what, tell me what which one should I wear. Okay, or your or you'll go to your father or your mother, and then you'll ask your friend. You will send pictures. You will ask them, tell me what should I wear. Okay, so what you are doing, you are getting opinions from different persons. Right, you're not only just you have just asked your sister or brother and you have okay you have said this so I'll wear this. Normally people don't do like this, right? They will ask to several person and then they will take the final decision, right? The dress which will get the maximum vote, you will pick that one and you will finally take the decision, right? Yes or no? Or you
Yes.
just simply you are so simple that you will pick out a dress. Okay, the first dress I want this is nice, I'll wear this. That's okay. Something like that you'll do.
No.
You will ask to several person, right? So, or you have to make suppose a decision like what should I do after this, after btech or after mtech, what should I do? Okay, you'll ask to several person and then you will take the decision. Similarly, we will give data set to several we will give data set to several algorithms. We will train our model based on this data set, and then on the basis of maximum voting or the averaging we will finally take the decision. This is basically ensemble. Okay. Now in ensembling, you will see random forest and many other things. So random forest is quite, you can say similar to your decision tree. Okay. Basically, we use decision tree there. So this is the reason I'm taking this topic well ahead before clustering. Okay. Because after discussing this decision tree, I generally move to the k-means algorithm, clustering algorithm. Okay. But this time I took this ensemble first so that you should have some similarity, some have some idea about this since you have idea about decision tree. Okay, now let's see the formal definition. So ensemble method, it's a machine learning technique that combines several base models in order to produce one optimal predictive model. Hmm. So it's a machine learning technique only, which what it will do, it will combine several base model. Base model means those different models to whom we have given the data set. Those will be the base model, or you can say the weak model, base model or weak model, in order to produce one optimal predictive model. Okay, that optimal predictive model will be a strong model. Hmm. So suppose this is my data set. Just give me a minute, okay? हेलो एवरीवन, थोड़ा स्लो। ये सर इतना जोर से क्या बोल नहीं।
और सर डॉक्यूमेंट
Sorry. Okay. See, let's suppose we have this data set. Okay, and in this data set, I will have several rows, right?
चांदनी क्लास ले रही है ना, थोड़ा धीरे बात करना।
Okay, now what will happen? I will give this data set to my different models. Now see how I'll give data set. One thing is, if I'm using, let's suppose different algorithm. Here I'm using decision tree. Okay, here I'm using SVM. Here I'm using KNN. Okay, and here after that I'm using, let's suppose, some other algorithm. Okay, let's suppose knife base. So if I'm giving, if I have different algorithm, what I can do, I can give the complete data set to these models. Okay, now this I can do. Another thing is, if I'm using, let's suppose here also I'm using decision tree. Here also is, instead of SVM, I'm using decision tree only. Okay, here also if I'm using decision tree. And here also I'm using, means I'm using same algorithm to my, I'm giving same algorithm for all the models. So what I can do for the randomization, I can randomly select data from my main data set, and I will give that data set to my first algorithm. Okay, then what I'll do, suppose here like 1, 2, 3, 4, 5. I have 5. Okay, so let's suppose 1, 3, and 4. These 3 rows were selected for my decision tree. Now what will happen? My data will be, see, this comes in next slide, but I'm already explaining you so that you will be able to understand those definitions. Okay, so what will happen? These, let's suppose 1, 3, 4 rows being taken in my, randomly taken into my first model. Then what will happen? Then again, this data set, so these rows will be selected from this data set and will be placed here. Okay, now how will be the selection? This will be the this selection will be with replacement. Okay, or means some random rows will be selected. It will not be like that 1, 3, 4 is chosen, that then it will not be chosen again. You can select it. Okay, means your when you will apply algorithm, they will randomly select, like 1 can come again. Okay, then let's suppose 4 it is taking, and then 5 it is taking. Okay, 1, 4, 5. Okay, this could be choosing 2, 2, 5. Okay, so there could be repetition. There could be some rows which are never selected. Okay, there can be some rows which are every time selected. Okay, so like this, rows will be selected. There could be repetitions in same model. There could be repetitions in different models. Like one is selected in DT, one can be selected in DT2 as well. Okay, one can be selected in another model as well. So those rows will be basically sampled, will be randomly selected from your main data set. Okay. Now, after selecting this data set, now what will happen? The data set is given to these models. Now this model will be trained. Okay, we will get a train. Yes. Are you saying something? Please mute yourself. Okay. Now, once this model is trained for all these data set, then what will happen? We will come up with a test data set. Okay. And we will give that test data set to every model. And we will ask these model to predict the output. Okay. Let's suppose we have two types of output. One says yes, another says no. And for my given test data set, this model is saying yes. This is saying no. This is also saying yes. And this is also saying no. So at the final stage, that result will be aggregated. and I'll get the final output. Suppose I'm using maximum voting criteria. So I'll say the output will be yes. Now this will be my strong decision. Okay, these were my weak models. This is my strong model. So strong model will give you strong decision, right? I hope this funda is clear to everyone. What we do in ensemble, if we have different model, we will give the complete data set to these model. If we have same algorithm for every model, then we will randomly select rows and will give to these model for the randomization purpose. Okay. Now this is the overall definition we have seen. After this, see, we have several ensemble techniques, like we can use maximum voting, or we can do averaging, or we can do weighted averaging. The advanced ensemble technique is bagging and boosting. Now, bagging is the term which is created of two terms. Okay, which is a combination of two terms, bootstrap and aggregating. Bootstrapping and aggregation. What is bootstrap and aggregating? Let's see here. Bootstrapping is when you are giving this data set to your different model. This step is bootstrapping. Giving data set to your different models, a random, and how data set you are giving. See, it's a sampling method, means you are randomly, means you are sampling the rows and you are going to give it to the different model. So it's a sampling method where sample is chosen out of a set. Okay, those basically I'm talking about those rows, data rows. Those rows will be selected out of a set, and using the replacement method. Okay, why it is saying using the replacement method? Because if I have selected first row in my first model, it will not be like that. I cannot use that in my second model. Those row will be placed again to the data set, and those row can be in sampling can be selected for the new model. Okay, so it is with replacement. Now the learning algorithm is then run on the sample selected. Okay, after this after giving the data set, these now the training will be done. Okay, here training will be done for the given data set. Okay, now see, the learning algorithm means the algorithm which we have chosen that will be used to train your selected sample. The bootstrapping technique uses sampling with replacement. Sampling with replacement to make the selection procedure completely random. Please make sure that you remember this terms, that in bootstrapping we do sampling with replacement. Okay. To make the selection procedure completely random. When a sample is selected without replacement, subsequent selection of variable are always dependent on the previous selection. If you do not choose the random data rows from your sample, then every time what will happen? So for example, I have, let's suppose, 10 rows here. In my first, I have selected 1, 2, 3. In my second, I have selected 3, 4, 5. Okay, like this I have selected, and none of the rows are repeated in my different models. And then what will happen? Every time they will give the result, that result will be overfitted for the particular trained data. Okay. So this is the reason, to avoid this, we use the random rows. Okay. Now, aggregation is the term which we have just seen, that the result we are aggregating. This is aggregation. Okay. So aggregation model prediction undergo aggregation to combine them for the final prediction, to consider all the possible outcome. All the outcomes are considered, and then the result will be aggregated and the final outcome will be taken. The aggregation can be done based on the total number of outcomes of the probability of prediction derived from bootstrapping of every model in the procedure. So basically, they will get the result from bootstrapping, and finally the result will be aggregated. This what we have discussed. This we have discussed is bagging. Okay, bagging is bootstrap aggregating. Okay, now here only you will see random forest. I hope these terms are clear. If you have any doubt, please ask. Then I'll proceed further. No doubts? Now, bagging is explained over here, like given a sample of data, multiple bootstrapped subsamples are pulled. How? They are randomly put, they will randomly pull the samples. They will randomly pull the rows. A decision tree is formed on each of the bootstrapped subsamples. See, this, please don't get confused over here. Maybe I have mistakenly mentioned here that a decision tree is formed on each of the bootstrap subsamples. Okay, this decision tree will talk about when we say that we are specifically talking about random forest. Okay, if you are not talking about random forest, then you cannot say a decision tree is formed on each of the bootstrapped subsamples. So basically, a model is prepared out of the subsamples, not the decision tree. Decision tree you can say when you are talking about random forest. After each subsample decision tree has been formed, an algorithm is used to aggregate over the decision tree to form the most efficient predictor. I guess I have to change the terms over here. Whenever we talk about bagging, we cannot say that every subsample, for every subsample, a decision tree will be created. Okay, if we are talking about bagging, the if we are talking about bagging, your bagging can use different algorithm. Okay, it could use decision tree, it can use KNN, it can use SVM. Okay, different algorithm it can use when we are talking about ensembling. Okay. No, actually, we can see when we talk about simply ensembling, when we talk about ensemble method, then we can say that we will use different algorithm. Okay, but if you are talking about bagging, then you can say that a decision tree will be formed. Okay. Now, it is used to aggregate over the decision tree to form the most efficient predictor. If you are clear with that diagram, I hope these terms are clear. Like we will have training data set, main data set, and from the training data set, we will have some sample data set. Okay, that will be called as bootstrap sample. Okay, because this is the bootstrapping step. Okay, that data set will be given to different algorithm. Okay, since we are talking about decision tree, let's suppose we are giving to the different decision tree. These data set we are giving to the different decision tree. Then it will classify. Okay, and the classified that the final result will be combined, and the result will be combined, and a final result will be given. That result will be predicted. This is shown. This is the same diagram which I have explained earlier. Now, random forest algorithm. Here you will see a slight difference when we talk about random forest algorithm. Basically, what happened? See, everything will be same. There will be slight difference. Okay, let's see what's the difference. Firstly, we will have the main data set. Okay. Now, you know that from the main data set, you will pick randomly, you will sample data set and you will give to the different decision tree that you know, right? I have taken from this main data set, I have taken D1 data set and given to my decision tree 1. Okay. Then I have taken D2 data set and given to my decision tree 2. Then I have taken decision data set D3 and given it to the decision tree 3. And there could be n decision tree. Okay. There could be n decision tree. There could be n data sampled I have given. Now, what happened here? There is one more randomization as well. One is randomization we have done in dataset. Another is we do randomization in attribute. Remember that dataset. Let me come to so maybe it is not changing. Just carefully. Okay. See, suppose I have attribute in my data set ABC. Okay. But when you are creating decision tree over here, right, you have random data set. Okay, sample data set over here, D1 data set. Okay, now when you are creating this decision tree, maybe instead of considering all three attributes, you are considering only two attribute to select your root node. Okay, then for next you are selecting another two combination. Maybe for another one you are selecting only one. Like this, attribute selection will also be randomized. Okay, like all the attribute we are not taking into consideration. We are randomly selecting some attribute, and based on that we are calculating entropy and information gain, and we are making them root node or leaf node or something like that. So there are two type of randomization. Not two type of randomization, but we here we are giving at two places we are giving randomization. One is in picking data set, another is in picking attributes. Okay, once this is done, then finally we will give a new data set. Our model is trained. Okay, now we will have some new data set, test data set, which we will give to every model, and we will ask to predict the output. Okay, let's suppose it is picking yes, it is also saying yes, it is also saying yes, and it is saying no. So the maximum one will I will take aggregate and will give that as an output. Yes. In random forest, I have given you there was a slight difference that along with the data randomization, even to pick the attribute. Remember, you have solved that weather data set. There were several attributes there, and you have considered all the attributes. You have calculated the entropy for all the attribute. Then you have calculated the information gain for all the attribute. And then finally, you picked up one attribute as your root node. But here we are doing a slight modification. Instead of selecting all the attribute to create your decision tree, we are randomly selecting some attribute, and for that, taking that into consideration, we are generating decision tree. Okay. So there will be different levels when you create decision tree. There will be root node, there will be internal node. So at every level, we are randomly selecting attribute, and then we are creating decision tree. Is it clear to everyone? The slight difference, how we are bringing randomization in our random forest. So we are creating several trees, several decision tree, and how those decision tree are different from each other based on their data set and based on their attribute selection. Okay. Clear, everyone?
Yes, sir.
Okay. Now, it is a supervised learning technique because we are talking about decision tree. Decision tree is a label data set. So obviously this will be a supervised learning technique. Now, it is used for both classification and regression problem. Because decision tree you can use for classification and regression problem. It's a cart algorithm. Okay. Thereby, random forest is also a cart algorithm which you can use for classification and regression problem. It is based on the concept of ensemble learning because you are using different learning models to get a final output. This is the reason it's the concept of ensemble learning, which is a process of combining multiple classifiers to solve a complex problem and to improve the performance of the model. Random forest is a classifier that contains a number of decision trees on various subsets of the given data set and takes the average to improve the predictive accuracy of that data set. Okay. So when you are using random forest, then for learning model, you will use decision tree as an algorithm. You cannot use different algorithms for your learning models. Okay. You have to use decision tree only. Another thing, instead of relying on one decision tree, random forest takes the prediction from each tree, and based on the majority vote of prediction, it predicts the final output. Okay. So instead of getting the result only from the one tree, you are getting the result from the several decision tree. Greater number of trees in the forest leads to higher accuracy. As you will increase the number of decision tree, your accuracy of the output will increase. Okay. Clear everyone, random forest? Okay, quickly tell me, with how many terms your bagging term means bagging is consist of two terms. What are these two terms? We have just studied bagging.
Bootstrapping and aggregating.
Okay, and what is bootstrapping?
It is a sampling method.
Hmm. It's with replacement, without replacement.
Using the replacement method, I guess.
And if we will not use the, if we will do it without replacement, then what will happen? Only one student is answering. What about others? If we will not do that replacement thing, then we will face the overfitting problem. Okay.
Okay.
See, this is diagrammatically explained what is random forest classifier, which I have just explained. Just give me a minute, okay. So we have X data set. From X data set, we have taken different features. Okay. See, features means attributes. We are taking different attributes. Along with that, we are taking different data set. And different trees we are creating. Means with different feature and different data set, trees will be created. Those trees will give different outputs for a given test set. Okay. Then we will do the majority vote and finally output we'll get. Now, these are some steps that firstly select random k data points from the training data set. Okay. Some randomly some k points will be selected from the training set and that will be given to the decision tree. Let's suppose decision tree 1. Then build the decision tree associated with the selected data points. Okay. So now decision tree will be created based on those data points. Now you have to select the number for decision tree that you want to build. Okay, you have to tell you want 5 decision tree, 10 decision tree, or how many. You have to tell the number. Then repeat the step 1 and 2 because for every decision tree you have to give the number of data points. Okay, and you have to select the subset for decision tree. Then for new data point, find the prediction of each decision tree. New data points means testing data set. For the testing data set, predict the values and assign those new data points to the category that wins the majority vote. According to the majority vote, categorize, give them the value. Okay, means I have one test data set I have given to every decision tree, and once I receive the result from them based on the majority vote, I'll say that this will be yes or this will be no. Okay, like this. This is the implementation. I don't think that it can be covered today. So implementation, okay, I'm just giving you the explanation today, and tomorrow we will implement this because I need to cover this boosting as well. This boosting thing, na? Remember, we have seen
Yeah.
bagging. We have to discuss boosting as well. So I'll try if I can show you the implementation today or not. See, these are some of the points when you will do the implementation, how you will fit your model, fitting decision tree classifier to your training data set. So, uh, I have asked you to search about sklearn library. sklearn library provides the implementation of several algorithm, several classification and clustering and regression algorithm and many other algorithm. Right. So we have seen that random forest is a supervised algorithm which can be used to implement classification and regression problem both. So this is implemented in sklearn. So from sklearn ensembling, we can import random forest classifier. And here, when you will train your data, before that, you have to set the things like how many decision tree you want. And estimators means we are telling that how many decision tree we want. 10 means 10 decision tree we want. Criterion equals to entropy that we have seen into decision tree as well. Can anyone explain this thing? And what is the other value we can take instead of entropy? Can anyone tell me what will be the other value for it? Remember, I have told you to solve decision tree numerical while I was solving. There are two methods. One is entropy. Another one is
Information gain.
no entropy. Information gain you calculate after calculating entropy. That is not the other method. Another method is
Index.
Gini
Gini
index.
index.
Yeah.
Okay. So the criteria we have taken here is entropy. If you want, you can choose Gini index as well. After all, even after calculating Gini index, you can calculate and you have to calculate information gain. Okay.
Yes.
So, so this is the criteria you have to mention over here. And what is this N estimator? I have just told you. Your algorithm, when you are applying random forest, that algorithm do not know how many decision tree you want. You have to explicitly tell that how many decision tree you want. If you don't mention, by default it is 10. Otherwise, you can mention maybe you require more than 10 decision tree or less than 10 decision tree. Okay. So you have to mention there that how many decision tree you will require when you are implementing random forest. Okay, so this N estimator is basically number of decision tree in this portion. I
Okay.
like this here. Okay, here are 4 decision tree. You have to mention how many decision tree you want, right? Then this is the after you have set the values, you have to fit your data set. And in data set, we are passing X train and Y train. We are not passing X test or Y test. Why? Here in this third point, classifier dot fit X train Y train. Why not X test Y test? Why not X test X test X train X test? We have implemented decision tree, right? If you can remember by that point.
Okay.
You are training your model over here in this third point.
Third point. Yes.
You are training your model, and that model is in classifier, right? In classifier, you have stored that there will be random forest classifier where there will be 10 trees. Criteria will be entropy that you have stored in classifier. Now you are training your model. Classifier dot fit X train Y train. So what you will
The
give?
test
You will
part is
give
already cleared on second one, right?
yes. You will basically give here train data set, right? So
Yes.
X train and Y train we are giving, not X test and Y test. That we will use when we are trying to find the accuracy. Okay. If you are
Okay.
training your model, you will give training data set. If you are testing your data set, if you are trying to find out the accuracy, you will give the testing data set. Understand why we have passed these values. Clear to everyone?
Yes, sir.
Okay. Now, boosting, I think it's the high time. We will discuss boosting and implementation of this random forest classifier tomorrow. If you have any doubt, please ask. If anyone have any doubt, can ask. No doubt. Those two problems are still unresolved. Okay, so try to resolve it. Come up with your solutions and doubts. Study what we have learned today. Okay, study about bagging, study about ensemble techniques. Okay, study about random forest. Tomorrow we will see its implementation. Along with that, we will see boosting.
Okay, ma'am.
Okay. Okay, ma'am.
Okay, then let's meet tomorrow. Bye bye. Take care.
Thank you.